There you go. Good afternoon, Facebook and YouTube. And I'd like to welcome you to our live stream. But before we start, let's have a word from BricsCAD.
BricsCAD is computer-aided design software for people who build things. It's the best choice for drafters, designers, architects, and engineers. It's highly compatible with everything you already know. It's based on industry standard DWG for both 2D drafting and 3D modeling. BricsCAD leverages the power of artificial intelligence to help you work faster and more accurately. Hundreds of third-party applications run on BricsCAD to power your workflows. BricsCAD is a design platform that runs as one product, end-to-end. BricsCAD BIM is a unique CAD-accurate building information modeling system that keeps design first. BricsCAD Mechanical brings a familiar workflow to mechanical assembly design, and it works with BricsCAD BIM to enable the design and documentation of manufactured building products. No other CAD vendor can deliver on this promise. BricsCAD is cost-effective. A BricsCAD perpetual license is half the price of a yearly subscription to that other CAD program. Try BricsCAD today.
All right. So for today, there you go. So good afternoon. My name is JP Titik, and I'd like to welcome you to our Bricsys Digital Summit 21 launch. JP Titik, and I'd like to welcome you to our Bricsys There you go. So before we start, I'd like to invite everyone to register here. This would be our registration page. So do register. Everything is in the description below. You can just read the captions and you can register there. So kindly register to our Bricsys Digital Summit version 21 Southeast Asia edition launch. And of course, while waiting for our speakers, do download BricsCAD in this page. Okay, so you can try all of the BricsCAD features using the ultimate trial. It's yours for free for 30 days. Okay, sign up to download right here. And do join our pages on Facebook and LinkedIn. So we have a group. It's BricsCAD Users Philippines. It's on LinkedIn. And you can check us. You can check us at BricsCAD Users Philippines. Please join our group. And please like our pages, BricsCAD Philippines on Facebook and CAD in Cloud in Facebook. So might be watching right now in CAD in Cloud in YouTube. So kindly subscribe to our page also. Okay? And everyone gets a chance to win a LinkedIn Learning subscription good for 3 months. So do join and register. So we'll be giving away a LinkedIn Learning subscription good for 3 months. Okay? So I'm going to transport you now to our webinar. So if you would have questions, right? So kindly drop your questions and then we can forward this. If ever we can answer it live, we'll do something about it. And if not, we can forward this to our speaker and then post the answers on Facebook. So make sure you like our page and do join our groups, BricsCAD Philippines. So we will be discussing this afternoon. Some of the key topics are BricsCAD Core Session, Imagine Unlimited Design Capability. So we're going to present you BricsCAD version 21. And BricsCAD BIM Session for BIM enthusiasts. Bricsys Design First Path to Building Information Modeling. We also have Bricsys Leica, Scan to BIM to Field. And for BricsCAD Mechanical, what's new in assembly design, sheet metal, and documentation. For Bricsys 24/7, how we can collaborate effectively in design, engineering, and construction. So make sure you download BricsCAD today using our links here provided in the Facebook and YouTube page. And of course, register to our webinar. And if you're going to share this live stream, do use our official hashtags. Hashtag CAD Alternative, CAD Essentials, CAD in Cloud, BricsCAD, BricsCAD Philippines, BricsCAD Users Philippines, and make CAD fun again. Okay. So let's just check. We can already join the webinar. Okay. So they're just preparing something, and while waiting, do check our pages. We would appreciate if you hit subscribe here in our YouTube channel, CAD in Cloud, and do share it to your friends, especially the CAD enthusiasts out there. So we're offering BricsCAD, and if you would have question regarding BricsCAD, kindly drop it in the comments, and we'll answer it. If you would have any inquiries regarding purchases for BricsCAD, do also drop it in the comments below. And right now, no, if ever that you're going to register, I'll just tell you more about the LinkedIn Learning subscription. So LinkedIn Learning subscription would be 3 months free. All of the lessons in LinkedIn, in which our group is based, you can have the lessons for free. You have to go to LinkedIn Learning and check out. Use the search bar to see the lessons that you would need. I myself, through my I wanted to build my channel, Titogenic TV, here in YouTube. I just used LinkedIn Learning to learn more about photography and video editing, and how to make good video and how to do good audio for my videos. So basically, if you want to learn something, you can just use LinkedIn Learning for it. And 3 months, imagine 3 months of online lessons here in Academy Cloud. It will be given for you for free. Okay? And it's valued at $90. So do register, do watch our webinar, and at the end of the show, we'll be raffling off a free LinkedIn subscription, and we will be announcing the winner on our Facebook page, both CAD in Cloud and BricsCAD Users Philippines. So here it is. This would be our page in Facebook. So do like and send a message. And we also have CAD in Cloud. There you go. So here would be our Facebook page, CAD in Cloud, and BricsCAD Users Philippines. Okay. So apart from the ones we registered, and we'll be giving away free LinkedIn Learning Premium for them, right? So we will also be giving away a free LinkedIn Learning subscription if you're one of the members that's going to add. If you're one of the members that's going to add 40 people to our Facebook group. So if you know any CAD enthusiasts out there and would like to get a LinkedIn Learning free subscription, then you can join our promo and just add 40 members, and you can win a LinkedIn Career Premium and Learning subscription. So you can learn a lot of things from here, not only CAD, not only photography, not only filmmaking. Almost all of the technical lessons that you're looking for is in LinkedIn Learning. Okay. And the LinkedIn Career Premium helps as if you're a LinkedIn member, you're looking for employment, job offering do pop out every now and then. So you can just add 40 new members to our group. Preferably those are looking for we're looking for CAD enthusiasts, right? Or people without experience who would like to learn more about CAD. We're willing to help them learn and get them started in their career as CAD enthusiast and applications engineer. So there you go. That's our promo. So I'd like to say hi to the people watching while waiting for our webinar. Okay? So stand by, stand by.
BricsCAD is computer-aided design software for people who build things. It's the best choice for drafters, designers, architects, and engineers. It's highly compatible with everything you already know. It's based on industry standard DWG for both 2D drafting and 3D modeling. BricsCAD leverages the power of artificial intelligence to help you work faster and more accurately. Hundreds of third-party applications run on BricsCAD to power your workflows. BricsCAD is a design platform that runs as one product, end-to-end. BricsCAD BIM is a unique, CAD-accurate building information modeling system that keeps design first. BricsCAD Mechanical brings a familiar workflow to mechanical assembly design, and it works with BricsCAD BIM to enable the design and documentation of manufactured building products. No other CAD vendor can deliver on this promise. BricsCAD is cost-effective. A BricsCAD perpetual license is half the price of a yearly subscription to that other CAD program. Try BricsCAD today.
We'll just be fixing some technical difficulties and be right back.
work of art using BricsCAD. With our new convert to solid command, you can now convert meshes directly to solids using this command. And post the conversion, the direct solids can be edited using our intuitive modeling tools. BricsCAD V21 brings new advanced tools for infrastructure modeling. Creation of thin surfaces is possible from multiple file types like CSVs and text files. You can assign raster images to thin surfaces to design in context and use clipping planes to do so. We can then start defining alignments as objects used to precisely define the horizontal infrastructure. Alignment alignments have horizontal, vertical, and 3D alignments. In V21, we have added supports for spirals and parabolas as well. By defining the horizontal alignments, we see that the vertical and 3D profile curves are automatically created using accuracy factors. We can now open the vertical profile editing view. We have now two alignments. Here, the cyan defines the existing ground and then the design profile, which also can be created automatically. We can then specify the accuracy factor to specify how closely the alignment fits to the existing ground profile. Then we can also switch to manual editing mode, where we can edit manually the profiles. We can remove and add PVI points and perform grip editing. We can see the radius, station, and elevation for each of the PVI points. In V21, we have added corridor functionality. We have first created the templates using simple polylines, after which we will attach the elements to the corridor templates. We can here have several templates in the drawing. We can attach multiple elements to the template. The templates can then be used to model the corridors. First, we select the 3D alignment and assign a particular template. The corridor will be developed as a real three-D geometry by specifying the start and the end station, and apply different templates for various segments of the overall alignment. If we select the corridor and switch to the properties, we can see for each region in the start and the end station. We can switch on and off different graphical representations of the corridor entity. It's not limited to meshes. You can also look at frame structures with which the corridors are built. Now we shall develop the embankments of the corridor to define the cut and fill slopes with respect to the terrain. First, we can extract the edges of the corridor as polylines. Then we can use the polylines to create a grading and define the slope of the grading to create an embankment. Now we can modify the 3D alignment, and using grips you can see that the corridor updates in real time. We can perform both horizontal and vertical changes to the PVI points. We can see that the tin surface is overlapping with the existing ground terrain, and now we can cut the required ground to fit our corridor and make it constructible by using tin surface editing tools. To hide the cut area, we can now visualize the road corridor design. We can merge different tin surfaces to create a overall tin surface, and then edit the tin surface of the actual ground and hide the chopped boundary of the tin surface to make our road correctly visualized and not overlapped with the terrain. So in this case, I'm selecting the cut geometry, and by hiding the cut geometry, I will be able to visualize the real bridge after modifying the terrain correctly, which will also define your cut and fill quantities. Post the modifications, you can also add pillars, railings, and also parapets can be. Automation in point clouds has been one of the most awaited features of the V21. The new point cloud features for V21, you can now import E57 files inside BricsCAD. We use three main principles to develop the new point cloud features in BricsCAD. In BricsCAD Pro, we want point clouds to be high performance, fast and easy to edit and navigate. To import point clouds 5 times faster, we have added new file formats, and bubble views at scan positions are created during the imports. Secondly, for BIM users, we want to create 3D geometry with smart algorithms. The geometry follows the reality, and as it is, can also be imported in a skewed manner, and we can give feedback for its deviations to the users. And finally, we allow BIM users to create 2D floor plans based on point clouds. We can attach and align point clouds to the specific UCS. We can crop them and automatically detect volume sections with the detect flow command. These volume sections can then be used to generate 2D drawings with the background raster image attached as part of the auto-generated 2D drawing. We can adjust with a series of parameters to improve the final result. Now in this case, we are using the auto detect tool where the wall detection tools and the tolerances can be defined. A lot of performance improvements in point clouds were made using background processing and multi-threading, and we added a progress bar. So in this case now, the 2D drawing generation is in process in the background, but we are still able to navigate and work in the foreground. So the bar gives a feedback to the users. We can now see in the final result, we get a high resolution raster image and lines, which can further be optimized using the new optimize command to start developing a floor plan or a section. Further to these amazing features, we can now generate 3D geometry in BIM by accessing inside the bubble viewer. The bubble viewer opens as a separate window which has three viewing modes. The first one is the natural color. The second is the vector mode. The colors give information on the direction of the surface. The blue is perpendicular to the z-axis, red and green to the x-axis and y-axis. And the third view mode is the depth map, which gives information on the distance. To create geometry, we can use the fit planar command to automatically detect surfaces and rectangles. By selecting surfaces, you can detect rectangular shapes and contour shapes. By using the points in the scan positions, geometry creating is very fast. Now, fit planar can also be used in the model viewer, which may be beneficial in certain circumstances where there is an odd point cloud. To work with all types of point clouds that are there. The geometry created with fit planar can now be used further to model walls and connections. So we are seeing that this auto detect is able to detect surfaces and convert them to walls automatically. And further to that, now the geometry created can be used to model walls and connections and create BIM elements and spaces. So with the combination of BIM workflows and the new V21 features, we can generate high quality graphical images that can be annotated as normal BIM sections. As you can see in this historic church example, we have added a modern elevator with the point cloud as a background. And BIM section can be annotated with tags and spot elevations. With BricsCAD's unmatched point cloud scan to BIM has a new life. We look forward to support you in your projects and deliver a better design and construction workflow with BricsCAD's unlimited design capabilities. We will now move on to our next session on BricsCAD BIM. I will now invite my colleague Claire to take over the stage. Thank you.
Hello and welcome again. For this next session, we'll be talking about BricsCAD BIM. We'll be talking about the latest developments to BricsCAD BIM workflow. BricsCAD BIM works with this thought in mind, a building design workflow that keeps design first. What does this mean? As a team of architects and engineers ourselves, we are aware that the typical BIM design process is a broken workflow that involves multiple tools that do not exchange data in a consistent way. As a result, you spend a lot of time in manual, redundant, and repetitive work to create and recreate the deliverables needed in each phase of the building design lifecycle. It is our goal to deliver an automated end-to-end workflow for architectural design, construction documentation, and building product manufacturing. By leveraging automation, we let you focus on what you do best, which is the design of your building. We will walk you through this end-to-end workflow in this presentation. In the first part, we will explain how you can start sculpting your conceptual design in BricsCAD BIM. Conceptual design is where we convert our ideas into a massing model to help us understand the project from a 3D massing view. Unlike traditional BIM tools, you can use an intuitive push-pull direct modeling combined with a parametric modeling, which is not limited by predefined parts or libraries of components. As a result, you experience design freedom with a full 3D workflow that will feed immediately in the BIM later on in the process. We can use direct modeling, import a geometry, or use grasshopper connection to create a massing model. Now what we are seeing here is a direct modeling approach to sculpt a 3D volume and create the shape of the building that we have in mind. Next, we are using a custom script to slice according to X, Y, and Z directions, and then remove the partially sliced cells to achieve the shape that we want. As we see here, we are just using this structure panel to edit out a few of the other components, and we can have different alternatives to this form study. We'll see a few more of those studies here. With the building massing we created, we can now show a first example of automation. We're going to use Quick Building to transform our model to an LOD 200 model automatically. Quick Building will shell the mass volume and it will automatically create walls, slabs, and spatial elements, like spaces, buildings, and stories. We created a section plane, and we can see that the walls and slabs have been created. We can use the structure tree to isolate slabs to see how the model was created. Now, as part of V21, we have introduced a new quantity framework that allows you to configure user-defined quantities. Let's see that. In this case, let's create a user-defined quantity for the compactness of the building. This can be calculated by using the formula gross volume divided by the total surface gross area of our building shape. Let's input that now. And once done, we will be able to see the new information in the Properties panel on the right side. And let's see that. We'll go down and see that here, the compactness is now shown. What we have seen is a transformation of a mass model to a concept model with floors, slabs, and spatial elements. This can be used now for evaluating design options not only geometrically, but also with quantities like compactness or floor-to-site ratio. Last year at the Bricsys conference, we announced a multi-year initiative to advance scan-to-BIM technology involving point cloud, in cooperation with our partners HOK and Leica Geosystems. We will see more of that in a separate session. Now, we will discuss more on other automation developments in BricsCAD BIM, which our partners from HOK helped to guide. This cooperation with a very respected name in the industry creates a solution that is based on customer requirements. In the next part of our presentation, we will develop our concept model into a full information-rich BIM information model. BricsCAD BIM leverages the power of artificial intelligence through machine learning algorithms to automatically convert your concept study models to a fully classified BIM model. Now, before we go into the automation part, we would like to introduce the demo model that we will be using in the remainder of this presentation. The Kentucky International Convention Center, a 90,000 square meter building with exhibit space, a conference theater, over 50 meeting rooms, and a full-service kitchen. This model was developed in collaboration with our industry partner HOK to to test the performance and scalability of new developments in BricsCAD V21 in a real-life project. Let's now hear from Greg Schleichner, a design technology director at HOK, about how we work together with industry partners like HOK to advance our future roadmap.
When we started working with Bricsys, we chose an existing project to reverse engineer, i.e., take a project we've already built, designed in other platforms, and rebuild that and use that basis of our work. So last year you saw the model reconstructed. This year you're going to see it used in demos. One of the main areas we focused on was drawing automation. And specifically, we started with something like fire life safety, which is a lot of effort. So you can see here, these kind of drawings are really laborious to produce. And so that was the basis of the collaboration. We think this way of working is a perfect process to go back and forth, to use the work that we've already done and help engage and add to the development of Bricsys.
The first and foremost challenge with working with this kind of large-scale project is, of course, performance. Our strategy to handle big models is very simple and straightforward. Split it up in smaller parts. All these separate models are combined into one master model, which is still slow to open when it contains a large number of models. To address this, in BricsCAD V21, we introduced background loading of XREFs. We can open the large master in just a second while all the nested submodels are being loaded. Independent of the size and complexity of the XREFs, the master model opens in the overall structure is displayed in low detail, while detail XREFs load. This allows you to already inspect data up front, like building and story information. Now that the entire model is ready, we will focus on a smaller part. Here would be the main mezzanine of the southwest part of this entire model to show how we go from geometry to BIM using our AI tools. Let's now open the mezzanine model as a separate DWG file. Now let's see here from the structure tree. Let's just go to the structure tree and see the entities, and we will see that we have about 410 solids. Now we want to convert these solids into information-rich BIM entities like walls and slabs. And normally this would be a lot of manual work, but this is where automation comes in. In BricsCAD, BIMify does auto-classification based on machine learning algorithms that were trained on a large database of BIM models. And now it's able to detect BIM types based on geometric attributes of the solids. It now starts scanning the entire model to classify, detect buildings and stories, and spaces. The goal here is that BIMify does the majority of the work, but as a designer, you can still overrule or change the classifications manually. So for example, here in the structure tree, let's just go here and see the building elements. And let's see the building elements. Actually, these are furnishing elements. So we can see these, and now we can actually select these and reclassify them as furnishing elements. And now we can go back to the structure tree and isolate some walls to see how the model is structured. And we can see that BIMify actually successfully classified these walls. And that's great. Now we will see how we can create and work with the new spaces in BricsCAD V21. Other than classifying objects, BIMify also automatically created spaces in the model. It found enclosing architectural elements in the model, such as walls, slabs, and columns. And it created spaces, and these are now space objects. Let's see those. And we see in the structure browser, we can isolate these. And let's see what that gives us. we'll see that these are actually solid objects. And we can also represent them by a footprint, like what we're going to be doing now. Let's see that. We can do that from the properties panel. And we'll get a very clear overview of the spaces in our model. Of course, these spaces are still linked to their enclosing entities. So meaning, let's see here, for example, let's move one wall. So let's say we move a wall, we'll see that the enclosed space will be flagged. And let's see that. We see here that exclamation point is telling us that now it's out of date and we can update those accordingly. And let's do that here. And we see that. Now, in order to further increase the level of development of this model, we can also start adding compositions to the walls and slabs. For example, for this model, we can see that there are coverings on the structural columns, which can serve as fire casings. So from the structure tree, we can easily select all the coverings and apply compositions by drag and drop from the composition panel. Now, after this is done, we can increase the LOD even more by applying details from our detail library. In this case, we want to apply a skirting board detail to the column coverings, which will help to improve air tightness and serve as additional protection from heavy objects. We can drag and drop or propagate the detail throughout the model. This means that it will scan and find all possible applications of the detail in the entire model by trying to find the exact same situations in the model where this detail can be applied. This saves a lot of time and also allows you to increase the level of development in the model consistently, not only in a single place. In this case, we see that we have 128 applications that Propagate has found. We can manually select the indicators to choose whether to keep or ignore these details. So as a designer, you still have full control. If you accept the changes, the geometric applications are directly applied to the solids in all the detected places. As a next step of automation, it is possible to use scripting Python, which is a high-level intuitive syntax for usage in BIM without needing a lot of development knowledge. So for example, we are interested to see some key numbers about this model, occupancy of the rooms or the areas of different types of rooms. So using Python, we can easily visualize the data using one of the many Python libraries that are available. So the results of the area and occupancy analysis can be shown in real time from the BIM session. And this gives us insight on how the model works. So up to this point, we have actually seen a lot of AI to automate tedious parts in the BIM workflow. And why is this? What is exactly the vision of the Bricsys R&D and AI team? It actually goes back to the process. About 80% of the time spent in a BIM project goes to labor-intensive repetitive work, while only 20% goes to the actual design work. Think about all the BIM data that needs to be added to the model, creating and recreating details over and over, as well as generating and annotating drawings. This is why the Bricsys R&D and AI team focuses on intelligent design, and they focus on assistant tools that automate these repetitive tasks and give time to the designers, architects, engineers to focus on what really matters, the design and problem solving. Now, we've seen quite a few of these tools earlier, but there are other opportunities for improvements. We see that the drawing generation, for instance, is typically taking a lot of time and manual work. So another one would be checking of design requirements in your model. This brings us to the next step in the workflow, which is construction documentation. Creating the documentation for a building project is often the most laborious and error-prone part of the architect's building design workflow. Our goal here is to create clear and accurate construction documentation and give the user complete control on how the 2D drawings will look like, including automation of tab placement and drawing customizations. Then, these automatically created sheets can be freely annotated and dimensioned using the 2D drafting tools that are available natively in DWG, while the drawing views stay in sync with the 3D model. Our master model was created by combining several XREFs. Section planes and elevations were created for each of these, and as a result, the entire model now has more than 700 section volumes. Now we have isolated one that we can discuss further. The project browser can be used to create and manage your construction documents using your company standards. It gives a full overview of all of your sections, sheets, and models that are part of your project. You can open a sheet to see how it looks, including title blocks and views. You can automatically add composition tags as well. The information shown for these tags is of course customizable. So let's add a couple of these composition tags to illustrate these. You can also add spot elevations to show the finished floor levels or FFLs. And we will be seeing that. And let's add a couple of those as well, just to see this illustrated clearly in the demo today. Moreover, you can also do dimensioning easily. We'll see that here, and other annotations, you can also do those while your 3D model is still kept in sync. So that's very useful. Now, how about other automation tools to make the process even smoother? Let's now talk about how we can take advantage of more automation in BricsCAD BIM. We see here two drawings. On the left, fire strategy. On the right, space strategy. They're actually pertaining to the same floor plan, just showing different information. This is typical in larger projects. We have several 2D drawings derived from 3D models, for example. Construction drawings, structural view, fire and safety documentation, and others. So in order to avoid a lot of the manual work when creating these drawings, the Bricsys team developed drawing customizations. Drawing customizations are templates that you can create once and reuse in all your projects. You can create rules on how certain elements with certain properties are shown on a specific customization. So for example, you may want to show 1 hour fire rated walls as red and other walls with a different fire rating to be shown in a different color as well. Hence, a lot of touch-ups in your documentation drawings are no longer needed, and a lot of potential errors in the process are avoided as well. Let's see that in action. We start from a sheet with two viewports of the same section result. The end goal is to create two types of customized plans, fire safety plan and space area plan as we saw earlier. Drawing customizations are closely linked to properties in the BIM model, so we go first to the 3D model. Let's go back there. So we have added information about fire safety properties in the BIM, half an hour, 1 hour, and 2 hour fire ratings. So we see that in the properties panel. And we will be selecting walls in the structure tree, and we will see that the walls will also have the corresponding fire ratings. Depending on the fire safety property, we want to give the walls a different representation on our floor plans. So step one would be to define the actual style definition. So we want to define how different types of lines will look like. For example, for walls with 1 hour fire rating, we want the intersection fill to be shown in red. And of course, we can also control all other line types here. Secondly, we don't want to just override how the walls look like, but we also want to change how components show up on plans, particularly doors, automatically operated doors. So let's do that. using a special tab. We can choose specific symbols to show up. So we can use an external DWG file for that symbol. And step 3 would be to define the rules to map properties to this specific tile definition. So we will be using the rules of the walls and the doors that map the properties and the customization. We'll see that. And we'll be applying the customization to the viewport. And we will be seeing that the colors of the walls and the tags for the automatically operated doors are reflected on the plan. Now, earlier we also saw that there is a second example, the space area plan. We use the same floor plan and we add a second customization file, which we actually already prepared. This one adds color to the spaces according to the function. So for example, a kitchen, a storage, a toilet, and we will see that the floor plan is easier to read. So one of the advantages is that definition of customizations are external to content. You can use this different kinds of geometry like supported Rhino geometry, IFC, and others. You can also create customization based on company-wide standards and reuse them in different projects. Now let's move on to the next part of the process, and I will let Sagar, our technical lead in APAC, take over from this point.
Thank you, Claire. Welcome, everybody. In this part of the session, we will discuss the new enhancements to the visualization and collaboration functionalities of BricsCAD BIM. As an architect or designer, you probably want to showcase your first design steps to your client. Last year, we announced a partnership with Enscape for real-time, high-quality rendering as part of the Bricsys Collective. This year, we are proud to offer a new member of the Bricsys Collective, Twinmotion from Unreal. Belinda Erkin, Product Marketing Manager at Twinmotion, will talk about the value this new integration can add to our customers.
This partnership is going to bring the whole range of Twinmotion's real-time capabilities to all BricsCAD users. Twinmotion is part of Epic Games, the developer of the Unreal Engine, and Epic Games brings a wealth of knowledge, history within the real-time technology space, where we have been pioneering and continuously driving real-time technology advancements through the engine. So we are very excited to help leverage the power of BricsCAD's unique and smart feature set with Twinmotion enhancing the architectural design pipeline. And one of the essential core features of Twinmotion is that you can skip the time-consuming import and export process, because with Twinmotion you can really rapidly bring CAD data or BIM data over to Twinmotion through the one-click direct link synchronization, which will be a plugin inside BricsCAD, and it will enable you to easily import your files into Twinmotion directly. And then once you're inside Twinmotion, it's easy to learn and use because Twinmotion was designed this way. It was designed to be simple and easy to use by combining this intuitive icon-driven interface, drag and drop assets. You have these beautiful one-click workflows. So you'll be able to get started quite quickly and be productive right out of the box. So overall, it's a very intuitive experience, and BricsCAD users can be excited about all these new ways of visualizing your data with Twinmotion, having the Unreal Engine as the underlying technology. You can create beautiful visualizations and animations with a really smooth user experience. So thank you very much, and we are looking forward to seeing you create such compelling stories.
We will now look at this model created in BricsCAD BIM, and we will export the master model as a single file. All XREFs will be included using datasmith file format DS, which is used to exchange data with Twinmotion and Unreal. We see that we can create renders and animations in Twinmotion, starting from an imported datasmith file. When importing the datasmith file into Twinmotion, you will notice the same structure as in BricsCAD BIM. So you can find the same XREF names, layer structures, and same classification types. This makes it very easy to navigate through your model. Twinmotion comes with a big library of textures and assets which are very easy to apply. For instance, we can drag a concrete material onto these columns, and you see that the texture changes at the same time. Same can be done for glass. We can simply drag and drop this texture, and it instantly makes the model look more realistic. We can also add other assets such as trees and other vegetation. Let's now see some renders and animations made using Twinmotion. In the final part of this session, we will focus on collaboration. BIM is not just about working in isolation, it's about creating, sharing, and collaborating with project partners across the globe. So we need to ensure that everyone can work together regardless of their design platform. In BricsCAD BIM, we enable this collaboration through the use of open standards like IFC and BCF, which is the preferred way of BIM information. As a complementary workflow, we also offer different interoperability possibilities with other BIM authoring tools like Rhino Grasshopper for generative design, and now with V21, also with Revit through RFA and RVT imports. We at Bricsys believe in the open BIM approach. That's why Bricsys is an international member of Building Smart, the organization that creates the open standards needed to make that possible. The first one is IFC, the open software independent file format used to share data-rich BIM models. With IFC, you can combine different models, architectural, structural, MEP, and so on, coming from different modeling tools into one federated building information model, where you can do quality checks, clash detections, and much more. BricsCAD BIM also let you import IFC files. What's amazing is that all the building elements are loaded as native objects, and you can edit them just like any other object. That's what OpenBIM is truly about. No more closed systems, no more closed file formats. BricsCAD BIM is even IFC certified, which guarantees the quality and reliability of the workflow. But that's not all. In a typical BIM project, you also want to communicate effectively on issues, change requests, and so on. From now on, we can do that with BCF, the BIM collaboration format. No more back and forth emailing, trying to describe what the issue is. BCF immediately lets you zoom in on the exact location where the issue is, show you who needs to resolve it, and how urgent it is. We already supported multiple BCF platforms, and now we can add BIM track to that list. By fully supporting the open BIM approach, and continuously improving both IFC and BCF support, BricsCAD makes collaboration easier than ever. For this demo, we will start from one part of the roof structure of the KICC that spans the entire exhibit hall. We are going to show an BCF IFC workflow to resolve an issue in the model. Using the Issues panel, we can connect to several BCF services, including BIM Collab or BIM Track, where we can see a list of all open issues that needs to be addressed. We see there is one issue about a missing connection detail between beams, so we can check the issue to go to the correct location in the model. To resolve it, let's propagate a detail from the Details panel. We have prepared a detail with the connection for steel beams with a plate and fasteners. Upon dragging and dropping, Propagate will scan the model and find all possible applications where this can be applied. After this is done, we will accept all 48 connections. If we zoom in, we can see that the detail has been added and the issue seems to be resolved. So we can add a comment in our issues panel. We can say that the issue has been fixed and ask to check the integrity of the bolted connection. We can add a screenshot and add the comment to the issue. A second part of an open BIM workflow is working with IFC. We have worked on performance and stability of IFC, but we also added several improvements like internal BIM types with IFC types, which gives them more control over how entities are exported and imported to IFC. We see that we have now exported this model of the roof structure to IFC. Once that's done, we can open the IFC model in an IFC viewer. For example, in our Bricsys 24/7 common data environment to see what it looks like. So Bricsys 24/7 is a fully functional cloud-based collaboration design platform where you can store all your files, all your design files, all your documents. You can review these files and you can upload and download anytime and have direct access from the BricsCAD 24/7 panel inside the software. In V21, we have also added improved interoperability possibilities with other file formats, including Revit models and families. In order to do this, we work together with Open Design Alliance, who has built a BIM SDK to support interoperability with different file formats. Open Design Alliance is a non-profit technology consortium that develops interoperability solutions for CAD and BIM industries. They partner with Building Smart International to support open standards such as IFC, and they also provide toolkits for proprietary design formats such as Revit. To show the Revit functionality, let's start with an empty drawing and import a Revit file of a typical office building. We can import the file as an underlay, or we can directly import the Revit data as native solids. We can also choose to filter the Revit data by view, categories, levels, worksets. In this example, we will import by categories. For example, we want to import the floor plan layout without furniture, spaces, and current flow terminals like light fixtures. We can do this by excluding them from the dialog. After this, we can then see how the import looks like in BricsCAD. In this version, only the geometry is imported, but we can use tools like Bimify to turn the geometric models into building information models. Once the model has been BIMified, we can check the structure tree and we can see that different BIM types have been detected. We can isolate the walls and slabs. We can see that they have been detected correctly. So this new Revit functionality enables a workflow where you work together with stakeholders or teams that work with Revit data. For example, we can start doing an interior layout by adding office desks and try different layouts directly on this imported Revit data. But of course, other workflows are also possible. We see that this new Revit import functionality is a complementary workflow to working with open standards like IFC, enhancing design collaboration capabilities for different teams across the globe. Another question that we hear often is how BricsCAD BIM allows multiple users to work together on the same model at the same time. The requirements for such a collaboration systems are not straightforward. Architects want the possibility to work offline on multi-user projects, so not having to be connected with the cloud server all the time. Also, architects don't want to work with huge files, which they have to send across for each and every small change that they want to make. Why need to download entire file if you only need a small adjustment? In V21, we have worked on a multi-user workflow that is based on Git versioning control and is built on top of DWG. Version control is a system that records changes to files over time so that you can recall specific versions later. It is a proven solution for collaboration, well known in other industries like software development. It also allows architects to collaborate with other users across the globe, as every architect can check out files locally from a central server. The advantages are that everyone knows what everyone else is doing, and administrators have control over who can do what. Also, it allows you to work with smaller models, so there is no need to download the entire model if you only need to make a small adjustment on a specific part. It also allows you to work offline as well as online on multi-user projects, so it does not require you to be online all the time. Now available as a beta functionality in V21. In this presentation, we have shown several ways to automate parts of your BIM workflow. In the future, we want to continue to follow this direction and take away the error-prone and time-consuming parts. On the modeling part, we want to make it easier to increase the level of detail of your BIM using tools like Propagate and Copy Guided, but also make it easy and intuitive to do conceptual design. On the BIM part, we want to automate going from a concept model to an information-rich BIM using tools like BIMify and the ability to create quantity takeoffs from your BIM. On the construction drawing part, we continue improving automation of dimensioning and annotations on the 2D drawings. We hope you enjoyed this presentation and we look forward to your feedback on BricsCAD BIM V21. And now, for the next session, I would like to welcome our colleague from Leica Geosystems, Mr. Neil Ashcroft. In this presentation, you will witness the revolutionary collaboration for scan to BIM and BIM to field workflows, powered by Leica's high-definition surveying technology and BricsCAD's powerful 3D modeling and cloud collaboration.
Great, thanks for the introduction. My name is Neil Ashcroft. I'm the Regional Technical Manager for Leica Geosystems here in Asia. And this session, I'll be talking about the field to BIM and the BIM to field workflows. So without further ado, let's get going. So at Hexagon, we believe in fusing the real and digital worlds to create dynamic and actionable data. With the combination of our sensors and the software solutions we provide, it is our intention to transform the geospatial industry we serve. So we need to digitize this reality and leverage on the content that we capture. Tools of the past. This is really about educating the decision makers. What will happen to companies that don't meet their customers' digital demands? Will they grow or even exist in the next 10 years? The measurement tools of the future are digital. At Leica Geosystems, we only have one product range left that's entirely manually operated, the optical levels. So on the left, we see the manual, the analog technique of measuring distances. On the right, the new norm, using digital tools to measure distances electronically and subsequently store the observations inside the sensor. And then we can transfer to the computer and upload into various digital design packages. From the start to the end of a project, Leica Geosystems is providing efficient solutions, helping to create a smart digital world. And each of this stage is a real business opportunity, reinforcing this link between real and digital world by making our customers more and more efficient, saving them time, saving them money, and thereby increasing their revenues or expanding their markets. Reality is now captured with laser scanners. Such a scanner seen here rotates around its axis, emitting a laser, which then measures angles and distances to remote surfaces. Inside or outside, the actual reality is measured and made digital. Here we see the resultant measurements, many individual points, or a point cloud. The first representation here shows the intensity of the returning laser. And the second representation overlays true color to allow better interpretation of the objects being scanned. A recent addition to the family of Leica laser scanners is the BLK2Go, a handheld mobile laser scanner that measures interiors to precision accuracy of 2 to 3 centimeters. So yes, indeed, a nice point cloud. Now what do I do with it? These point clouds can contain millions, if not billions of points. Using a Leica CloudWorks plugin, this enables tools such as BricsCAD, Cyclone 3DR to create models, compare against existing models, determine clashes, and even enable data sharing. Actionable real-world data. So by taking these point clouds into the likes of BricsCAD, we can then do dimensions and take measurements as if we're in the real world. A point cloud delivers a complete 3D picture. See the spaces between spaces, and virtually visit your assets, especially relevant during this time of COVID-19. This allows us to base our design on reality. Be assured that the design decisions that are made are accurate and achievable. However, modeling from scan data is quite time consuming, so really only model what you have. The point cloud is the truth, so use that alone where possible. The data can be used to validate these existing plans and models to ensure what we are given is accurate. Other tools like the CloudWorks plugin for BricsCAD do allow some semi-automatic creation of geometry from the point cloud. The best fit geometry to the point cloud to speed up the process and improve the accuracy of created models. It's not completely automatic. There is some need to do some manual processing, but you can quickly create 3D models using the point cloud as a reference. The deviation checks allows us to identify any pre-construction, particularly in renovation projects, where we can understand if an area of the site may need additional work to make it ready for construction, such as grinding down an existing concrete slab. Capture and validate the positional accuracy of any component. We are able to check the facade of a building for any potential movement or deviations from a design intent. And then by creating a heat map, we're able to share this information in an easy to understand way, allowing us to make quicker decisions. So I'd like to introduce you to the intelligent construction products within Leica Geosystems. This is the Leica Icon product portfolio. So the Icon products we're talking about are the GNSS sensors. Those are the ones in the poles, and total stations, which you see on the tripods. These are fundamentally setting out coordinates from your design model on long linear structures such as roads, railways, tunnels, or vertical structures such as buildings. Okay, let's put what we have seen to a short video. So this is a full end-to-end workflow of capturing reality using a laser scanner. The resultant point cloud is referenced into BricsCAD using Leica CloudWorks, whereupon a 3D model is created. Additional design components are then added for subsequent setting out back in the field, transferring using Bricsys 24/7. So let's go. Great, so I hope you spotted the Bricsys 24/7. It was exporting some DWG files, the final DWG files, out to the field. So this ensures that the latest version is always available for the surveyors out on site. So after transferring the IFC file or DWG or even the DXF file onto the icon sensor, we can start to set out boundaries. We can start to set out the building footprints for the construction of the towers or the structure. We can also run QC checks to make sure that the buildings are put in the right place. So this is what the icon total station looks like. And this is the tool that we use to go from the BIM design off to the field. So in summary, a recap of the life cycle of a building or a construction site, from the initial surveying using various tools for capturing the reality, the planning into design software like your Bricsys suite of products, setting it out, taking it across to the icon products, and doing some setting out for utility underground services, and then the actual construction where we need to make sure that the building is progressing as designed, and then some of the validation before we hand it across to the end user for the facilities management and the operations of the building. So there we go. Any questions at all? Or maybe perhaps we'll wait till the questions at the end. Well, thanks very much. I hope to speak to you soon. Bye-bye.
Wow. Thank you, Neil, for enlightening us. That was really informative. Good afternoon, everyone. My name is Arvind, and I'm a technical support analyst at Bricsys. Let me walk you through some of the new and exciting features in BricsCAD Mechanical V21. If you did not hear about BricsCAD Mechanical before, then you probably consider it as just another toolset to create 2D mechanical drawings. While 2D drafting is perfectly possible with BricsCAD, we at Bricsys strongly believe in 3D. Three-dimensional modeling allows designers to fix errors at early design stages, analyze different aspects of design products, generate NC code, and technical documentation. While BricsCAD Mechanical is not a toolset for 2D drafting, it is also not just another mainstream 3D mechanical CAD. There are serious differences of BricsCAD from other MCAD softwares. First of all, with BricsCAD, you don't need to spend your time and money to study a completely new software with its own GUI and design principles. With BricsCAD, you always remain in the same familiar environment, which was extended with few intuitive tools. Secondly, with BricsCAD Mechanical, you will be more productive in design thanks to our unique technology of 3D parametric components and hundreds of vertical applications from our partners. You can easily implement your own tool or application using our Lisp or VRX API. Third, BricsCAD does not pretend to replace your current CAD system. It is ready to collaborate in multi-CAD environment. You can continue to use your different CAD tools, but with BricsCAD, you will never have headache with file formats, which lose design intent in translation. I believe no other CAD system in the world has so powerful tool set to rework imported geometry using a combination of direct editing operations with automatic history-free parameterization. Each year, our quality assurance engineers test new functions of BricsCAD Mechanical on a completely new model. This year, we were inspired by the idea of Maltese cross mechanism. This is a gear mechanism that translates a continuous rotation of the driving wheel to an intermittent rotation of the driven wheel. It was modeled in BricsCAD using 3D constraints and expressions. And this movie was recorded in BricsCAD using Animation Editor, which allows you to create complex scenarios of 3D parametric animations with different effects, including appearance or disappearance of particular parts, kinematic simulation, and camera movement. As you can see, this Maltese cross mechanism is a sub-assembly of the filling and capping machine. Through a conveyor, the bottles are moved under some filling valves that inject the liquid into them. After the filling, the bottles move up to the other side of the machine where a cap is provided for each of them. This model also has parameters, which allows to adapt it to bottles of different size. It is a large assembly which consists of more than 3,000 parts, of which 500 parts are unique. And this machine is part of a brewery which also has a lot of vessels connected with pipes to a water supply and the machine. A number of standard parts are used here, which is also typical for many other industrial assemblies. This complex model was designed in BricsCAD Mechanical from scratch using new and improved tools available in version 21. This year, we implemented the most popular suggestions of our customers and partners and extended the main tool sets which are sheet metal design, assembly design, and technical documentation with the most requested tools. Let's take a look at these new features with the help of this brewery model. There are a significant number of very useful new features in sheet metal this year. Let us take a look at the most powerful of them using two sub-assemblies of the capping machine. In order to demonstrate the new intelligent way to create sheet metal parts from simple solids, we will be using this control box. Let's convert them to sheet metal, and now for the bottom part, you can see that on clicking on the top face, bends, junctions and reliefs are created automatically at the same time. That's really wonderful. For the middle part, we just click on two faces, the back and the front, and everything is being automatically created. We just have to choose the kind of miter, which is very fast using the amazing propagate capability that looks for similar geometries and automatically applies the miter. In matter of seconds, it is done, and we can unfold the model. That is really amazing. Let's go now to the top part. First, we create the bends on the top face. You can see that the related junctions are automatically being created here. Then we repeat this on the two back faces. Everything is created automatically except for the miters, which again can be placed using the propagate capability, and it's just a matter of a single click. Now let's try creating the curved junctions on the bottom and on the top curved edges. We will be creating the junctions here. This looks really easy. We still need to make some minor changes to unfold this part. Thanks to the possibility to switch bends and junctions, we will be swapping the bends with the junctions on the two sides. Now we will be able to unfold the part. Another important new capability is the possibility to assign one body with its specific properties, despite the fact that we had converted all the parts together. Here, we're going to change the thickness of the bottom part. And you can see here, the thickness is updated for the bottom part alone, and the rest of the components retain the original thickness. And now we will go ahead and unfold all the parts. You can realize that in less than 4 minutes, we have converted the three solids into sheet metal, and we have also unfolded them. That is really amazing here. Next, we will be using this drum feature that distributes the caps that will be crimped on bottles to showcase some advanced features in sheet metal. We start from the shell state, what we call as poor sheet metal in BricsCAD language. First, we convert them to sheet metal. Now, we're going to add the bend to this small part that you see here. But you see there is a gap at the flange end. Now, we will be filling this gap using the sheet metal junction. Then, with a new T-tabs function, we can switch this junction to a tabs and slot inside the flange, and not only at the corner. Look at this result here. That's really amazing. But this is editable. We can change any parameter. For example, we can change the number of tabs to 2, and it is going to still retain the symmetrical feature. Now, we will add two small flanges to guarantee the perpendicularity. And let's try to fix the width to maintain the design intent. Let us see how the tabs are going to behave when we try to move them by moving the flange using the push-pull command. The tabs and slots are going to move accordingly, and the design intent is being maintained. Even when we try to rotate the flange, the tabs and slots are going to move correctly. Then, thanks to the new capability of BricsCAD 21, we can change the thickness of this part, and you can see that the tabs and slots are actually changed, and the design intent are also respected. And you can see there is no collision here. And of course, we can unfold this as well. Things get even better with this next capability. What about tabs on curves? First, let's set up a number of tabs to 0. It means that the number will be chosen automatically according to the distance that is being selected. Now just click on the round edge and let's see the miracle. We're going to get the tabs with the perfect distribution. Of course, we must create a junction to separate the parts, and let's do that here. And now to finish, just select the remaining parts in the rectangle and click on the create bend. These solids are now fully converted to components which can be successfully unfolded. Finally, we can go ahead and unfold all the parts. If needed, these drawings can be exported to DXF file format as well. All these features will help us to save a ton of time during the design process. But there is one more kind of part which is also very typical in the mechanical engineering. These are seamless and welded pipes, elbows, T's, crosses, reducers, and flanges, also called as pipe fittings. They are widely used in machinery, automotive, aviation industries, and also in oil and gas. In BricsCAD V21, we added a rich set of such parts of the most popular standards. We also streamlined the way to insert and connect them. The bottom-up design was never so easy, and we keep the freedom of direct editing in combination with full parametric control. Let's see this in action. I want to show you some cool new features and tools which we have prepared for piping design. Let's go ahead and showcase this with the brewery model, which was created from scratch in BricsCAD. As you can see, this model contains around 800 parts and more than 1,000 constraints between them. All these constraints were added automatically and during the new mode of BM insert command, which is called the smart insert. Let's check that even with such a big number of constraints, this model is workable. For example, to have access to the vessels, we need to add a platform between them. The original platform looks very big, but fortunately it is parametric. So you can easily change its dimension to adapt to the actual situation. Here, we need to change the height and the length. As you can see now, we have a problem. There are few intersections between the inserted platform and the existing pipe layout. We cannot change the platform since we want it to be as small as possible to save useful area. So we go ahead and change the pipe's layout. But actually, it's not a big problem. Since pipe layout is properly parameterized and we can just move it by manipulator or the move or the DM commands, and everything is going to move. For example, the placement or the pipe lengths will adapt automatically. So we need to move just one pipe and the whole line will move properly. There is still intersection with the valve. So let's move it also. Since our brewery has become bigger and bigger, workers will not have time to do everything manually. So we want to upgrade it by adding some automation. For example, by adding the filling line here. I think you remember this filling line. By sheet metal demo, we had used this filling line here. Here is a filling line and now it looks like everything is ready for connection. But we cannot directly connect the filling line with the layout. We need to add a pump. This pump will transfer the beer between the filling line and the vessels. We do not want to place the pump in front of the required flange because it will block the passage. So what we actually need is to place the pump behind the flange, but it again will cause of some modification of the existing layout for proper connection. So first what we do is we rotate the elbow with the flange. It can be done by any rotation command or just by manipulator. Such operations will preserve all required constraints. So layout still can be modified properly. Then we need to connect flange to the pump. We can just directly move it there or use the BM connect command, which was implemented to connect two components, which have information about how they should be connected. As you can see, the outer diameter of the existing layout does not correspond to the pump diameter. But again, we have properly parameterized the layout, so we can adapt diameter by just changing one parameter. So flange, the adjacent pipe and all the other connected pipes and tees will change the diameter properly. Let's continue. Now we want to connect the pump to the filling line. We can do it easily with the help of a new standard parts library and a new option of BM insert command called smart insert. Standard parts library have reconfigured to improve the usability. All existing parts are separated in three categories: fasteners, machine parts, and structural shapes. The category of piping with the 182 new parts are also added. Mostly it contains parts from the American standard, the German standard, and also the international standard, which is the ISO. Currently, piping categories include following parts like pipes, fittings, like elbows, returns, reducers, and eccentric reducers, T's, and crosses. A lot of different flanges as well. And finally, there are also the gaskets. So if we will drag a piping part from the library, by default, the smart insert mode of the BM insert command will be used. This mode can be used on components which store inside information about how these components should be connected to each other. This information is stored as point and line on special layers with the postfix connection. These entities represent connection point and the connection direction. Also, this mode recognizes which parameters of the base component can be used in inserted component and try to copy values or expressions of such parameters. This allows inserted part to adapt to base 1 and also will allow to create parameterized layout. One more thing which allows to create parameterized layout is proper constraining. So smart insert analysis inserted and base parts and decides which constraints should be added to them to allow correct further working. We continue with the creation. As you can see, when you hover inserted parts to base 1, its size is being changed. It will properly connect to base 1. Moving and rotating of such parts is still available and does not spoil the parameterization. Moreover, because of constraints, adjacent elements are adapting to the move. Smart insert can be used not only from library but also on already inserted components. As a final step, we need to actually connect the created pipes to the filling line. Here, for that, we are going to again use the move command, but in that case, we need to position everything correctly. But we can also do so using the specialized BM connect command, which will do it automatically. You only need to point out which two components should be connected to each other. And you can see here, using BricsCAD 21, it is possible to create the parameterized pipe layouts, which can be easily changed if needed. We just saw that assembling large parametric pipe systems in BricsCAD Mechanical is as simple as connecting Lego parts together. But to manufacture these assemblies, one has to properly generate the corresponding technical documentations as well. Let's see how to solve this task with BricsCAD Mechanical. In V21, we implemented new powerful tools to create associative two-dimensional drawing views from 3D models of mechanical parts and assemblies. Let me demonstrate these tools to you on the example of the beer vessel. According to the standard, the main view for the vessel is the section view. To achieve this, first we should create the base views beyond the layout and then create the section of the side view. Also, we can create the top and the bottom view. They can be later on annotated. The next part of the vessel are the most important. They are responsible for preserving the contents of the vessel. The middle manhole subassembly does not completely fit into our drawing, but we can easily change their scales using the command option. The command option allows us easy customization during the view creation. The next step is not so obvious and could take some time because the sub-assembly orientation is not known. It is not aligned with the coordinated axis. That's why to create the correct view for the top manhole, we use the view base command with the current orientation option. This option inherits the camera position from the model space and uses it in the drawing view. It allows to create the custom view quickly and easily. The space on our layout is limited. We also plan to add annotation tables and technical notes in the future. In V21, we introduced the new break view command that can reduce the drawing view area by hiding the fragments. Let's create a vertical dimension and check how it behaves with the break view. Now you see the vertical dimension keeps the correct value after the break operation. The break symbol has several properties. You can change the type of the symbol. For example, you can change it from spline to zigzag. And other parameters such as distance between the curves can also be changed. We support vertical and horizontal cuts and can combine both on one view. Fixation of the manhole door is achieved by using a threaded pin and knob. We've implemented the new DM thread command, which allows to create a decorative thread to display on the drawing view. Let's open the pin component and add the thread. Using the new tool, we can easily create the thread on any cylindrical face. You can configure the pitch, the length, and the diameter of the thread. Let's switch to the main assembly and create a drawing view of the pin. You can see that the threaded model displays correctly in the drawing views. We've put all the necessary views on the drawing. It will be finished later. Now I propose to switch to another drawing, a very special one. Our project partners helped us with a couple of drawings, but they have preferred to work on an old style manner using AutoCAD Mechanical. Unfortunately, after receiving the drawings, we noticed several mistakes that must be corrected. By default, when you open an AutoCAD Mechanical drawing, some specific symbols represented as proxy objects. To be able to apply changes to these objects, you need to activate the Mechanical 2D enabler like what we have done just now and reopen the file. After that, you can modify the 2D elements. We are supporting copy, move, erase, and other basic operations, but our capabilities are even wider. For example, you can see here the datum ID is being copied using the manipulator. In V21, we added the ability to change the properties for 2D elements from the property panel. We've corrected the feature control frame properties and now replacing the surface finish symbol. Another example illustrates the assembly drawing. It allows us to demonstrate the ability to change the balloon properties such as the balloon type. You can change it from circular to polygonal and arrowhead style. In our case, we use a standard arrow. We see that the part list overlaps by other balloons. So we have to correct this mistake and at the same time edit the support bracket material. All these manipulations will take us just a few seconds, and we did not ask the author for this document for any help. The next step in documentation in most mechanical drawings are tables. It can be a trivial part list or something more sophisticated. Bill of Material Manager of BricsCAD Mechanical allows you to create many kinds of such tables, and since V21, its capabilities became absolutely fantastic. I'm going to show you the most interesting features of Bill of Materials in BricsCAD V21. Let's start with this brewery model. With more than 3000 parts here, you will need a fast, flexible, and powerful tool to document and analyze. Good news is that the Bill of Material in BricsCAD does exactly that. For example, What if you want to see only the parts related to pipes, which this model has a lot? To list only the parts related to the pipes, we will add the part category column and use a new feature of BricsCAD V21 called column filters. Column filters allow you to quickly set criteria which to show the rows which we need, similarly to the spreadsheet processors. Here, we use the filter to select only the part categories related to pipes such as the elbows, flanges, pipes, reducers, and tees. This table now shows all the parts related to the pipes. But what if you want to know the total length of the pipe by the size? To find out, we copy this table and adjust the filter to show only the pipes. Next, we remove the component column and add the size and length properties. Normally, BricsCAD groups parts with respect to their components. In order to group pipes by their size only, we need to change the grouping mode to by columns only. In this mode, parts will be grouped only by the added columns, which is exactly what we need. To get the total length for each pipe size, we use another new feature called the aggregated function. Similar to the footers, they can also compute the sum, average, minimal or maximum value in the group. And you can still add them to the footer. Additionally, you can also set a column filter to find a specific range. Let's say in this particular project, I want to see only pipes between 50 and 100 meters long. This can be easily done using the aggregate function. Aggregate function and the column filters form quite a powerful tool, and we hope you liked it. Now, let me switch to a familiar drawing of the maturating vessel. It's almost ready now, and all we need to do is to add some specifications and annotations. Let's start with the material list. First, we create a bottom level bill of material and rename all columns to meet the company's standard. For pressure vessels, materials and dimensions for each part are also required. So we add the necessary columns such as the physical material, the part category, the part number, and the length. However, we want dimensions to be in one single column. So we create a template column from the selected ones. It's a new feature to combine several properties in one cell. It's based on the so-called diesel expressions. So even quite complex templates with conditions are possible. BricsCAD automatically adds delimiters between values, which you can adjust with your own text. Of course, you can configure template columns as you want using this template configurator dialog. Now all we need to do is to remove no longer necessary columns and add the table to the drawing. And now it's done. Isn't it impressive? Of course, we've highlighted only the most spectacular new features of the bill of material, but there are more. Please try them using the BricsCAD 21. Those were some of the new and exciting features in BricsCAD Mechanical V21. Our development team has already started to work on the implementation of new mechanical features, which will be released in V22 or during V21 release cycle. So please don't forget to send us your feature requests. We listen to them very carefully. And now, let me invite Claire again to showcase some of the exciting features in Bricsys 24/7.
Hello, and again, I'm Claire. As the APAC technical consultant who focuses on our cloud solutions, I would like to give you a bit more insight to our Bricsys Common Data environment. Aside from our all-in-one CAD solution, BricsCAD, Bricsys has also developed over the years a robust, secure, and easy-to-use cloud platform for collaboration. We currently have two solutions. The first is Bricsys 24/7. Bricsys 24/7 is used as a common data environment with the purpose of managing documents in and around AEC projects. The second, BricsCAD Cloud, is a BricsCAD-only product that is used for managing drawings from within BricsCAD. The Bricsys Common Data Environment solution is built around five key elements. The first and most important one is, of course, managing documents and drawings. You can easily upload and download files. There's an automated version control system, which allows you to go back and consult older revisions. Aside from a detailed activity log, powerful search capabilities, and automated notifications, a check-in and check-out mechanism is also available. So while you are working on your document, no one else can change it. You can also add any kind of information to your documents through configurable metadata. For example, adding an internal reference text so you can easily use the search filter to find it. Second, you can share all kinds of files and view 70 plus file types online, including DWG. You can also make remarks and have a choice to notify the whole project team or only certain project members about important comments on your drawing. When working with different team members, you want to make sure that the right data is in the right hands. On our cloud solution, you can easily set access rights for different user groups, or what we call roles. This is done intuitively, as the interface of each user is customized according to his access rights, meaning a user sees only the folders and action icons that are relevant to him. On our cloud platform, you can also easily set up configurable workflows. This way, you can automate processes such as assigning tasks, distributing documents, and processing approvals. With a graphical workflow editor, you can easily set up a workflow to automate document distribution, assigning tasks, document approvals, and notifications. Let's now see how an automated task and an approval workflow works in Bricsys 24/7. In this case, let's say you are Kin, an architect involved in the Sky Office project. Once a task is assigned to you, you'll receive an email notification where you can click on the link to respond. This will immediately bring you to your online project task. You can see the task itself, what question there is for you, as well as check out other information that is involved in this task. You can also look into the viewer, wherein you will see the drawing without having to download it. In this case, this is probably a DWG drawing. It includes any sheets or layout, as you see on the lower left side, and on the right side, you can also see annotations that are already there. You can also add to these annotations by adding an annotation. Let's say you want to say okay, but would like to change colors. You can choose to make this annotation public. You can add more description. You can add an annotation. And once done, you can click OK. And you will see that annotation already on the annotations list. You can also choose to use the arrow annotation, and also printing to PDF gives you the option on choosing what information to print. So let's say you're done with making comments. We will see that closing this dialog will bring us to the automated workflow where this task was assigned to you. Actions in green are done. Red is for your action. Yellow is pending action by other roles, in this case, the designer. Now you can approve this, maybe add a further comment to review the annotation that you added earlier on. And once you're done, you will see that the action that you completed just now has been changed to green, signifying that it is done. You may also choose to add a form to be filled out with metadata. Let's say you want to have a form for cost approval by a project director. Let's add a form now and see that we can rename this and have a title, approval by project director, maybe costing approval, and drag in the fields that we want. Let's have date, drag in a number field to put cost approval number, text for title, another text, perhaps longer one for description and reason for the cost approval request. And then let's actually also put some choices. They need to check one of these choices, and then we can also add in a cost field. Of course, this is a cost approval. We'll need that. And once done, you will see that this costing approval form is now in our list. Finally, let's talk about the last key element, the fifth one. So last but not the least is the possibility to perform actions outside the web interface. For this, we have a mobile app, transfer tool, the BricsCAD built-in panel, and integrations that are possible using our REST API. So with the mobile app, you can access, view, and mark up drawings, whether you're at the office or maybe on the field. With the transfer tool, it's a small desktop application that makes it possible to easily upload and download documents from or to the cloud. You can also drag and drop files and even full file structures to and from your online projects. We also have the Bricsys 24/7 panel, which is built into BricsCAD, which gives you immediate access to download your drawing, work on it, and upload it back to your online project without even having to leave the BricsCAD platform. Let's see how the built-in Bricsys 24/7 panel is integrated into BricsCAD to improve your productivity. On the right side, you will see a Bricsys 24/7 panel. It is the cloud icon there, and you can log in, put in your Bricsys account credentials, choose your project, and find your file within the folder structure, download it, work on it. You can also lock it to make sure that no one else can change it while you are editing something there. And then you can go back and upload it back to the online project that you have. You can also add in some descriptions or comments to what you have changed. And once uploaded, you will see that now it is up to date in your online platform. So those are the 5 key elements around which the Bricsys Common Data Environment was built. So let's see the two Bricsys Common Data Environments again, Bricsys 24/7 and BricsCAD Cloud. And here we will see the main differences between these two solutions. So when choosing which option is appropriate, it really is up to the company or project needs. If a certain company or project has a need for customized metadata, workflow automation, BIM model manager, some detailed reports probably, as well as no need to worry about the number of users in the project, Bricsys 24/7 will definitely be more appropriate for that. Now let's look at what we can look forward to Bricsys 24/7 in the future. We look at these 3 main pillars for the future of Bricsys 24/7. First, build further on our strengths. Second is interoperability. And third is cloud diversification. Let's talk about building on our strength. This will be focused on the ease of use of Bricsys 24/7. This is a very important aspect in which Bricsys 24/7 already does very well. Hence, we want to enhance this even more. And this is why we are building our new user interface. We will also expand further on the workflow functionality. It is already powerful to use the current Bricsys 24/7 workflows for your projects. From work in progress phase to sharing documentation with a broader team, moving to construction, and at the end onto the as built phase. And of course, we will improve our viewer technology in order to provide you with more actionable features to drawings that you store, such as maybe taking quick measurements from your drawings without even having to download them. Now, let's talk about interoperability. We recognize that it's important that we integrate with other solutions to enhance your experience. For example, looking internally within the Hexagon group, of which Bricsys is part, we have Ecosys that provides very strong construction management. We have built a really strong integration where our clients can manage their project in Ecosys while managing documentation in Bricsys 24/7 in a seamless way. Beyond the Hexagon family, we are looking into further integrations with best-in-class third parties, such as those for issue management, which a lot of our clients are actually already using. In this way, it will be more advantageous for our clients. We are also enhancing our API to make it easier for third-party developers to integrate and further improve the experience for the users. And lastly, which is the third one, onto diversification. The team is working closely with the BricsCAD BIM team for a multi-user environment. Also, we are looking into virtual reality, which we have already done a proof of concept with one of our clients. It is fully operational and functioning, and we are looking to scale that. Another aspect for cloud diversification is offering libraries where you can store elements which may be your company standards, authorized to be used for certain projects. So those are the three pillars as we can see here. One, building our strengths with ease of use. The second, interoperability by integrating with others. And lastly, diversifying our offerings. We hope this gives a bit of idea on the future of Bricsys 24/7. Thank you for listening and thank you for staying on. Now I would like to get back to Rashmi to close this session of our summit.
Thank you everyone for staying on. We hope you enjoyed the session as much as we did. If you have any questions, please don't hesitate to reach out to us. We wish you festive greetings from Bricsys family. Stay safe, stay connected with Bricsys. Thank you.
Thank you so much, everyone, for joining us this afternoon for our Bricsys Digital Summit version 21 launch. So I hope you learned a lot from this session. And of course, I'd like to invite you to join our communities, BricsCAD Users Philippine, both on LinkedIn and Facebook. And please like our page, BricsCAD Philippines and CAD in Cloud. Do subscribe here, CAD in Cloud and YouTube for more videos regarding Bricsys. And of course, make sure you register. In this video, we have a registration link here for you to be able to be a raffle winner of our 3-month LinkedIn Learning subscription. All right? So my name is JP Titik. Make sure you connect with me in LinkedIn, and I'll see you there.
BricsCAD is computer-aided design software for people who build things. It's the best choice for drafters, designers, architects, and engineers. It's highly compatible with everything you already know. It's based on industry standard DWG for both 2D drafting and 3D modeling. BricsCAD leverages the power of artificial intelligence to help you work faster and more accurately. Hundreds of third-party applications run on BricsCAD to power your workflows. BricsCAD is a design platform that runs as one product, end-to-end. BricsCAD BIM is a unique, CAD-accurate building information modeling system that keeps design first. BricsCAD Mechanical brings a familiar workflow to mechanical assembly design, and it works with BricsCAD BIM to enable the design and documentation of manufactured building products. No other CAD vendor can deliver on this promise. BricsCAD is cost-effective. A BricsCAD perpetual license is half the price of a yearly subscription to that other CAD program. Try BricsCAD today.